Back to page 6 on 8.6, we were talking about domain and why we needed to know what domain was, because we have to pick x values, and so we have to know what x values are okay. If I pick -2, when I plug it in, it's going to give me an error. If I pick -1, when I plug it in, it's going to give me an error. If I pick 0, when I plug it in, it's going to give me an error. So that's why we need to know the domain. So whenever you're doing the argument of a log, the argument has to be positive, and in math symbols, that means greater than 0. So any x values I put here must be greater than 0. So should we start with some decimals? Maybe 0.25, and then maybe 0.5, and then we could do 1, 2, 3. What about that? That way we get some values real close to 0, because if we go to 1, it's just going to be hanging. So we kind of need to know what's happening real close to 0, and then we can see what the rest is. So remember, this is the inverse of the exponential. The exponential had a horizontal asymptote of y equals 0. So since this one is the inverse, that means x and y are flipped. This one is going to have a vertical asymptote at x equals 0, because x and y get switched around on inverses. And this one is the mother function because nothing has been added, subtracted, or multiplied. It's just natural log of x. So then we write x equals 0. And they do ask you on ALEKS, on paper pencil tests, what to sketch that asymptote and to tell them what it is. So when the function has not been shifted left or right or up or down, well, up and down don't affect it, but left or right does, it's going to be x equals 0. So now we can plug these values in our calculator. So we're going to do ln of 0.25, ln of 0.5, ln of 1, ln of 2, and ln of 3. And if you remember, we said the log of 1 is 0, no matter what the base is. This is a base e, so I already know this one's going to come out 0. So the natural log, or the log of 1, no matter whether it's log base e, log base 10, log base 6, log base elephant, the log of 1 is always 0. And that's because e to the 0th is 1 when we do our loop and swoop. So we have ln, and we're going to start with 0.25, and that is about -1.4, it looks like. And then we're going to do ln of 0.5, close our parentheses, and that's about -0.7. You can try this one out if you want. ln of 1, boom, always 0. Log of 1 is always 0. It doesn't matter if it's log base 10 or log base e. And natural log of 2, close your parentheses, is 0.7, positive. And last, natural log of 3, close, is 1.1. Let's do one more since the numbers didn't get too big there. And let's do natural log of 4. I'm just going to hit my up arrow and turn that into 4. And that's 1.4. So now we have kind of a better picture of what's happening. Okay, so 0.25 would be about 1/4 of the way between 0 and 1, and it goes down to -1.4. So -1.5 would be in the middle, so -1.4 just a little bit higher. 0.5 goes down to -0.7. There's -0.5, so -0.7 would be about right there. 1 goes with 0. Every exponential has 0, 1 as a point. Every log that hasn't been shifted has 1, 0, because we switch the x and y around. 2 goes with 0.7, which is just a little above half. 3 goes with 1.1, which is just above 1, and 4 goes with 1.4, which is just below 1.5. So do you see the shape of the logarithm there? And do you remember that I can't cross or touch this line? This is an asymptote, so when I go to draw the graph, I need to make sure I just slide right along beside that line, but don't cross or touch it. And then going the other way and put arrows in, remember? Get everything centered. And then we finish the graph this way with an arrow on that end. So that is a log graph. If you need to look back at 8.4 to remind yourself of the log graph features. Every log has a vertical asymptote, and if they haven't been shifted left or right, up or down, they will have the 0.10 on the graph. So let's go ahead and do domain and range, since you're going to have to do those for the Chapter 8 test and the final. So domain, remember, is left to right. So as I'm rolling my pencil, I go, well, there's no values over here, so no negatives. It can include 0 because there's an asymptote, but everything after 0 is fair game. So 0 with a parenthesis to include it can't be 0, and then it goes to infinity. 0 to infinity. And remember how I said it's going to be the opposite of this one? So look at the one we just did on page 4. The range was 0 to infinity. On this one, the domain is 0 to infinity. It's because they're inverses. This was an exponential function. This one is a log function. So their domain and range get flipped around. And the range, remember, is bottom to top. And I see this one goes down forever, so the bottom value would be negative infinity, and the top is just going to keep going up, 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 up. It's going up slowly, but it's still going to keep going forever, so positive infinity. And if you look on page 4 again, what we just did in the last video, the domain became the range of the log. The range of the exponential became the domain of the log. So because they're inverses, exponentials and logs, you flip-flop those around. And there is my log graph. Done! So now this log graph is going to be this one, but take every point and shift it up 2. So move this one up 2, it'll be here. 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 And that will be that graph. So you could actually do it without a t-table. You could just add 2 to all these y values. But we'll pretend we don't have this one here. But you should recognize that it is just the mother function, which was above, shifted up 2. So let's go ahead and write that in. Mother function shifted up 2. Two units. There we go. And it's not with the x, because if it was with the x, again, as I said before, it would be in parentheses. That's why it's not a left or right shift, because it's not in parentheses. It's not with the x. It's just 2 added to the mother function. So since my argument is still x, so you can think of this like this. Since my argument is still x, my domain is still going to be x is greater than 0, because the argument has to be positive. So as I pick my values, I need to make sure that I pick values greater than 0. So let's do, should we do the same ones as before? 0.25, 0.5, 1, 2, 3, and we'll add in 4 just to get a little flavor there. And so then I just type in, and when I type it in, just FYI, it's ln 0.25, close your parentheses, plus 2. Don't leave your parentheses open. You need to tell the calculator that argument is 0.25, not 0.25 plus 2. And so it's supposed to be assumed when you see ln x plus 2 that only the x goes with the ln unless there are parentheses around it. So this would be the other scenario. So if the 2 went with the ln, then it would have to be in parentheses like that. But you don't want to type it in like this one. You want to make sure you type it like that. And then we have ln 0.5 plus 2, ln 1 plus 2, ln 2 plus 2, ln 3 plus 2, closing those parentheses, and ln 4 plus 2. So those are going to be what we type into the calculator. So first we're going to have ln 0.25. Close your argument to let the calculator know you're done, and then the plus 2 means shift it up 2. So that's going to be 0.6. And then ln 0.5, close your parentheses, then shift it up 2 is 1.3. ln 1 is 0 plus 2. This is going to be 2, but we'll go ahead and plug it in because remember ln 1 is always 0 because e to the 0th is 1. So ln 1 plus 2, there it is, 2. ln 2 plus 2 is 2.7. And let's just use our up arrow for the next one. 3, that would be 3.1. And then up arrow again and make that 4. And that would be 3.4. So again, you can see it's going up very slowly because it's not shifted left or right. The vertical asymptote hasn't been moved. The only time it gets moved is when the graph shifts left or right, but this is a shift up, so our vertical asymptote will stay the same. So let's go ahead and draw that in. So it'll be x equals 0 again. I'm making myself dizzy. Am I making you guys dizzy too? Yikes. When you look at the screen when the paper moves, it's like, whew. Okay, 0.25, which is next to 0, is 0.6, which is a little over halfway. 0.5 is 1.3, so right in the middle, go up to 1.3, a little under 1.5. 1 goes with 2. 2 goes with 2.7, 1, 2, a little over 2.5. 3 goes with 3.1, 1, 2, 3, just right above 3. And 4 goes with 3.4, which is a little under 3.5. So you can see your graph, just like this one, same shape, but just shifted up 2. So instead of crossing at 1, 0, it crossed 2 points up at 1, 2. So I'm going to move this slowly so I don't make anyone sick. So it's going to go down and crawl right along the asymptote, but never cross it or touch it. I'm going slow. And then it's going to, come up here and have arrows on both ends. Okay, we have 30 seconds, so let's do domain and range in those 30 seconds. So the domain, left to right, nothing, 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 picks up at 0 right after 0 and goes left forever. So that'd be infinity because domain's left to right. And the range goes down forever, up forever, so negative infinity to positive infinity. we are done.